Hey everyone! Thank you for joining us today for the special live stream. Today I've got our team member Ulrich with us. He's going to be talking to you about updates we have on SAP CDC capabilities in Azure Data Factory. So get excited. Make sure to drop your questions in the chat. We'll do our best to answer those at the end. And awesome. Let me bring in Ulrich so he can take it away.
Yeah, thanks a lot, Noel, for the introduction. And thanks to everybody for joining this session. So as Noel said, this is about an update on the SAP CDC capabilities we have started to deliver in Azure Data Factory earlier this year. Let me maybe start with the agenda for this session. So we'll get started with a short introduction for those of you who haven't seen our previous sessions on this. I think the last YouTube live stream we did was about 2 months ago, so it's been quite some time. So some people who might have missed this, for those guys, it would be an introduction. For others, it might be a recap. I'll keep this really short because in the end, we want to actually focus more on the other agenda items, which are, first of all, the lessons learned from the public preview, and I'll basically address some of the aspects where we saw customers struggle from a conceptual perspective, and basically then also explain the takeaways and how we have enhanced and evolved the solution over time. And I'll basically also give you a demo of the latest state, which we have delivered a couple of weeks ago already. So without any further ado, maybe let's jump into the agenda. So to set the stage, and that's basically for many of you who have followed what we are doing in the SAP connectivity or have been doing over this year. That's more of a recap. We have been focusing on integrating ADF with SAP's operational data provisioning framework, which is for short called ODP. ODP is basically, as you see in this slide, the central or one of the central pieces of infrastructure when it comes to exchanging data between SAP systems for analytical purposes. So on the left-hand side, in the like light gray box, you basically see what's happening inside an SAP system. So this ODP framework comes with a lot of SAP systems, basically all fairly modern ERP systems, S/4HANA systems, BW systems have this basically built in. ODP is basically like a broker between the SAP source system and consumers. Originally, it was built for SAP consumers only, but a lot of third-party vendors have adopted it as well. The main benefits of ODP, as opposed to the connectivity we used to have in ADF, and which also other vendors have in the SAP world, is that it basically exposes a rich variety of sources which SAP has built on purpose for data extraction, like the SAP ECC extractors. That's basically the technology and the infrastructure and the objects which SAP has built to feed data from SAP ECC systems, for example, into BW, into Data Warehouse Cloud, into SAP Data Services, all those target systems. Same for S/4HANA. So S/4HANA basically comes with a modernized technology, similar in flavor, but based on a different technology, which are the so-called CDS views. And again, SAP has built a huge number of objects for all kinds of application areas like sales, and we'll see that later in the demo as well. Sales, financials, all of those areas are covered by CDS views for extraction, just as it was with ECC extractors in the past. And the list goes on, as you see on the left-hand side. So all of this now becomes available to consumers and to ADF in this case, since we're basically leveraging ODP with our newest connector. Maybe just a couple of additional aspects, right? I mentioned the rich variety of sources, which I think is like the top capability and top aspect of ODP. The second aspect, which is probably about as important, is that ODP comes with built-in Delta or CDC capabilities. So many of these sources on the left-hand side have the capability to only deliver delta, so the change data since a previous load, And ODP kind of harmonizes this. The way the individual sources on the left-hand side are doing this are slightly different, but ODP basically puts a harmonized interface on top of that, which is also very convenient for consumers. And yeah, basically for those reasons, it's very simple to use, it's very robust, and it's also scalable in many ways. And maybe we'll come to that a little bit later, what it means from a performance and tuning perspective. So that's basically the stage about ODP. And now what we have done with ADF earlier this year, and you might be aware of that already, is that we have delivered a dedicated connector, the SAP CDC connector, which basically can connect to the ODP framework. In this slide, you see the high-level architecture of the whole picture. So on the left-hand side, again, the SAP part with the ODP framework and the actual sources from which the data comes. On the right-hand side, you see Azure Data Factory and a self-hosted integration runtime, which we have put into this architecture basically as a broker between ADF and the cloud and the SAP system. One of the benefits of using the self-hosted integration runtime in this scenario is that it basically allows us to reach out to pretty much any SAP system wherever it's installed, whether that's on premises, whether that's in Azure, whether that's in any other hyperscalers infrastructure. As long as you install the self-hosted integration runtime nearby the SAP source system, you will be able to connect Azure Data Factory to your SAP system and transfer the data. So that makes the whole the reach of this whole solution basically very, very large, and that's a great thing, of course. The second important aspect, which I always like to stress, is the way we have built this. There's no footprint on the SAP side, so there's no installation needed, no add-ons, no transports to be installed on SAP side. We're just consuming APIs as they are built by SAP and provided by SAP. So we have a very clear separation of the part of the solution which happens on the Azure side and the part of the solution which is on SAP side. Okay, I think that's enough of an introduction. If you want to know more, we have recordings from I think like 2 months ago where we did a live stream where I elaborated on this in a bit more detail. So please feel free to watch that. For today, I actually want to focus a little bit on some of the lessons we learned from the private preview or the public preview of this solution, and what we took away and what we basically included as lessons learned into our software. So I've come up with 3 main points here. The first one is that the extraction via the CDC connector and ODP works really well. So the process, as I said earlier, is very simple. There's no watermarking needed on the consumer side. ODP takes care of all of that. It's very easy to get the data out, right? You just, without any additional state management on the consumer side, you just ask for change data and the SAP system will take care of providing with the right data. So that's very easy, and that's also what we saw with customers, and customers really appreciated that. Second thing is stability. So this whole solution and the extraction of data is very stable. We had very few issues on that. So once the setup is done correctly with all the permission management and the user setup on the SAP side to connect, and the configuration on the SAP side is good, we actually never saw any major issues. And the last point is that the throughput, which we could achieve through, for example, reading in parallel out of the ODP framework, partitioning the loads to even parallelize the creation of the data or the production of the data on SAP side, we saw really high throughputs, and that's also all very encouraging and very, very positive. So on that side, we are very happy. The points 2 and 3 were more of a concern. So we saw that a lot of customers actually underestimate the effort to process the change data as it comes from ODP. And I'll basically get into this on one of the next slides to explain this in more detail. The thing is that the change feed, which comes from ODP, basically delivers kind of raw data. So first you get a full snapshot, which is easy to work with, right? You just insert it into any kind of target. But when you get the subsequent deltas, then basically you end up with like a feed of change records with additional metadata around them, which basically says, okay, this is an insert, this is an update, this is a delete, and so on. That's basically encoded in metadata, which is attached to the records. And processing this raw data meant a significant challenge to customers. So some customers have tried to do this manually and realized that this is not such an easy task. Of course, it's doable, but it's certainly not something, or it's certainly a point where you would like to have an out-of-the-box solution provided to you by an ETL tool. Now, we had a solution for that, which was providing mapping data flow templates, or basically pipeline templates, which first did a copy activity and then had a mapping data flow, which was designed to basically interpret the change feed in the right way, order the changes in the appropriate way, do some deduplication, all of that. The main drawback we saw when customers were using those templates was that they exposed a lot of internals in the UI, right? So if you looked at these templates, the mapping data flow templates in ADF, you basically saw the individual steps, and customers started to play around and tamper with them, right? So trying to understand what's the purpose of this specific step, and that easily results in errors, right? If that's basically some standard logic which needs to be executed that's in the same way all the time, and as soon as you start tampering with this, chances are high that you break this. Plus, so this kind of tendency towards instability of that solution was an issue which we saw with customers. Plus, the combination of having a copy activity and this mapping data flow in parallel also seemed a bit complex. Therefore, we basically went back and came up with a slightly different approach, which I'll explain in a minute. Let's now focus for a moment on this question about the change feed and why it's complex to work with that. So for the initial load, I have here a screenshot of the data as it comes from the SAP system. Of course, that's not all columns. I have truncated a lot of that on the right-hand side. This goes on forever. But you basically see here sales documents, headers and items. You see the document number, you see the item number, and you see a certain sequence number which we basically add when extracting the data from the SAP system. And then there are these two metadata columns which basically indicate what kind of change is happening. Now with initial loads, that's very simple because for an initial load, every record is a new record, so it's all inserts. Therefore, you only see pretty much zeros in this entity counter column and blanks in this change mode. So it's the same for all of those. It gets more tricky when you look into incremental or delta loads. So here I did an example where I updated and created and deleted a couple of sales orders, and you see that the changes which you get in between two subsequent runs of your pipeline of your pipeline, they typically contain multiple rows for the same key, right? So here, for example, you see the sales order 4643, and you see it here again, you see it here again, or similar with 4645, you see it here and you see it here. And on the left-hand side, you see what kind of change that was, right? So you see updates. Actually, this 4645, it was an insert. So I created the sales order and deleted it right away. Here you see the delete marker. So handling those changes right, as I just said, proved to be a kind of a significant issue for customers. As I said, some of the issues which occur or which surprise customers is that you can have multiple changes to the same key in one incremental load, potentially across multiple files, right? If your incremental load is big enough, it will land in multiple files in the target, and you would have to check across all those files what changes to a certain key are occurring. And the second thing, as I mentioned, is if you really want to make sense of that data, you can't just dump it into a target and just insert it, because you would end up with duplicates and kind of wrong data. So you really have to take into account the change mode here and apply the change mode in the correct way to the target. Now, what we took away from this and what we basically enhanced our solution with is the following. We basically came up with like a consolidation of the initial solution consisting of a copy activity followed by a mapping data flow template, and basically brought the connector into mapping data flow. So with the with the latest update, which we delivered a while ago, you can basically now use the SAP CDC connector as a source in mapping data flow. Right? So you see this here. I took a screenshot of a very simple example, which basically takes the data out of an SAP system. In this case, it's an S/4HANA system, and basically updates it into a sink, which is a delta table in the delta lake here. And we can look at this example later on in the live demo. So the configuration is pretty simple. So basically, when you do the source configuration, you have 3 tabs which you would care about. There's the source settings, the source options, and later on potentially the optimize tab. On the source side, you basically configure which type of data set you want, and you specify that you want a SAP CDC data set. If you go for an inline data set, you can of course also use a predefined data set and just put in the name of that data set then. And you specify the linked service, right? So that's basically what you do here. And the source transformation, that's the beauty of this new solution, does all the complex logic of interpreting the change feed in the right way. So it first of all copies the data from the source and lands it in some staging area, which you can configure. I'll show that later. It removes the duplicates, so it basically makes sure that across all the files which are written during copy of this incremental load or reading of this incremental load from the SAP system, it takes the latest change for each record, and it also interprets, of course, the ODP metadata, which we saw in this ODQ entity counter and ODQ update mode column, into inserts, updates, or deletes on the sink. Right? So it basically does all that logic out of the box, and in the end, this means that for like the simplest case or kind of scenarios where you basically have a source and you want to sync it with a sink, that's all you need to do, right? You define the source, you define a sink as the follow-up transformation, you configure everything appropriately with the source here and the sink, and you're good to go. So that's basically how this solution works. From a configuration perspective, let's briefly go over it, but we'll also see that in the system in a minute. Basically, on the source options tab, you can specify the ODP object which you're interested in. So you specify the context. In this case, I'm using an ABAP CDS view, and you specify the name of the CDS view, and you have 2 options for the run mode. So you can do like a full runs only, which is the second option, and the first option would be to do a full run on the first run and then incremental load. So that's the typical behavior which you do when you want to have a CDC process going on, right? You first do an initial load, which gives you a full snapshot of the current data, and you subscribe to a change feed of the ongoing changes. Right, and just as a detail, if you want to do an incremental load, you need to specify keys, because in that case, as we saw in this example of data which I showed you earlier, in this case we need to be able to deduplicate, and for that, of course, you need a key definition. All right, then before we move on to the demo, one last aspect, which is an optimization. I would say in the optimize tab, you can actually specify if you want to whether you want to partition the load. This only works for full loads as of now. So if you have a large full load with hundreds of millions of rows potentially, you can split this into multiple smaller chunks. So for example, partitioning by fiscal year, or even in finer granularity here, I'm showing an example with partitioning by fiscal year and fiscal period. So basically, each of those of those partitions, so that would be partition 1, that would be partition 2, will be executed on the SAP system in parallel. The SAP system provides the data for this partition in parallel with the data for this partition, and we also read in parallel from each of these two streams in ODP, right? So basically you parallelize on the SAP side, and we additionally parallelize the reading from the ADF side, and with this you get actually to significant throughputs for large data volumes. So yeah, with that, I think let's move on to the demo. I'll briefly share my ADF. So let's take a look at this in ADF. So here you see a pipeline calling a mapping data flow. That's basically how the setup works, right? We have this data flow activity here, and there's one piece of configuration which you have to make for this, of course. Generally, when you want to orchestrate a data flow, of course, you have to specify which data flow to run. You have to specify the Azure integration runtime on which this is supposed to be executed. And specifically for this scenario, you also need to add a staging configuration. So you basically need to specify a linked service and a staging folder where we basically land the data as it comes from SAP. So we are first reading the data from SAP, putting it into a staging folder, and from there, the mapping data flow, which we have configured here, will pick it up and process it and write it to the target. So next, let's look into the details of that mapping data flow. And you see it's quite a simple structure. We start with a source where we basically specify the details of the object within the SAP system we want to read the data from. Then I have added, just to exemplify where you would put your individual logic, one step which adds a derived column to this to the data coming from the SAP side, and the last step is that we are updating the data into a sink. So let's look at the source configuration here, and that's pretty straightforward and quite simple. So what I'm basically using is an inline dataset. You can of course also use predefined datasets, but mapping data flows also allow you to do this inline without having to predefine datasets. And on the source settings side, you basically specify the type of the inline dataset, so that's SAP CDC, and you specify the linked service which you want to use. On the Source Options tab, you actually specify the details of the extraction process. So you specify the object which you want to extract data from. So in this case, we are going to use an ABAP CDS view. And the specific name of the ABAP CDS view in this case looks a bit cryptic, but it's actually one of the CDS views delivered by SAP. It's actually the one which SAP provides for extracting sales order data. So it does a join of sales order headers and sales order items and delivers that data or provides that data for external consumers. The third option we have is the run mode. The run mode basically has currently two different options. So there's the first one is full on the first run, then incremental. That's the standard way the Delta process with ODP works. So when you when you run your pipeline for the first time, you will get a full snapshot. Subsequent runs will only get the incremental changes or the deltas since the first run. The second option is full on every run. That's basically, as the name says, not a delta process, but you basically get a full snapshot for every run of your pipeline. And the third option, which is currently still grayed out, will basically be similar to the first one. It will start an incremental or a delta process, a CDC process, but it will skip the initial run on the first run. So it will only deliver or only read the changes and not do the initial snapshot. That's relevant in scenarios where you basically already have the data acquired, this full snapshot acquired maybe with other mechanisms, or where you're migrating the data from one system to the other or from one table to the other. So you might already have that data somehow, and it might be like smarter to avoid the potentially large initial run in such a scenario and take the data from the existing sink, which you already have. In the case of full on first run, then incremental, so if you do a CDC process, it's also important to specify the key columns. ADF retrieves them automatically for you, right? So it basically calls into the SAP system to retrieve the key definition of the source object. And basically here we see that this This view which we're using has two key columns, which is sales document item, sales document and sales document item. And that's actually all that's required on the source transformation, at least for a simple scenario. So let's move on to the second transformation step, which I included. That's a derived column. So I'm adding a column called load time, which I'm filling with a parameter I have included in that pipeline. Here you see that parameter P load time, which basically, at least by default, takes the current UTC time and adds it as an attribute to the data set, which is retrieved from the SAP side. So that's also a pretty straightforward step, just exemplifying how you would integrate your own logic into this whole framework. So basically, after the source transformation, you can apply your own logic, and the last step will typically be to sync the data into the target. Now let's look at the specifications you have to do here. It's also not much. You need to specify the details of the target. So again, I'm using an inline data set here. I'm using a delta table in Azure Data Lake. And on the next tab in the settings, I'm basically specifying the exact folder path into which I want to write the data. And now that's the interesting part about the CDC process here. We can not only do inserts, right? We don't just dump the data, the raw data as we get it, but we can actually convert this into inserts, deletes, upserts, and updates on the sync. And as I said, ADF does this automatically. The source basically transforms these, interprets the metadata which comes with each record, the ODQ change mode and the entity counter, into internal row markers, which basically mark a row as insert, update, delete, upsert. And basically with this, we can use the sync mechanism to apply the appropriate changes into the data target. For this, you also need to specify the key columns, and I did this here in an expression using the two key columns which we saw earlier. I already ran this pipeline once to do the initial load, and I would like to check with you what we see on the target side now. So I have prepared two SQL queries. The first one basically does a select count star, so it just gives us the number of rows which we have in the sync now. The second one is a bit more tricky. It also does a select count star, but it only filters for those records which have been updated in the last 10 minutes. So we have this load time, that's the derived column which we're adding in our pipeline, basically has a value which is less than 10 minutes ago. And we should not see any records there because I ran the initial load quite some time ago. So let's run these two statements and check for that. We should see something like close to 6,500 records in the table in total, and a 0 for the second query. So let's check that. So query 1, which is the second query, really results in a 0. Query 0, which is this one up here, basically gives us, close to 6,500 records. Now let's move on to the SAP side, create a new sales order and update an existing one, then run the pipeline again and see how the results are reflected on the sync side. So let's move over to SAP and create a new sales order based on an existing reference sales order, which I'm using here. Maybe let's adjust the quantity here. And go through the process on SAP side. I think we have to enter a customer reference, then save. It should be fine. And we see that sales order 4655 has been saved. So we created one sales order now. Next thing I wanted to do was to update an existing one. Maybe let's use this one to update. Let's say, okay, we increase the quantity here, double it. Again, go through the process here. Everything looks good, I think. And we have successfully updated that sales order. So now going back to ADF and executing this pipeline again, we would hope to see that these two changes are reflected on the sync side. The pipeline starts running. And while the pipeline is running, let's move on to the Synapse side and check for the changes we see on the target. So by now the pipeline should actually have finished. And with this query, I'm basically selecting all the records, all the rows in the sync, which have been updated within the last 10 minutes. So we would expect to see the two records which we have just created and updated. And let's verify this. And as you can see, we see the sales order 4655, which we have just created, and also the sales order 4654, which we have just updated. So let's shortly summarize what you should take away from this demo. Basically, what you've seen is how simple it is to use mapping data flows with the SAP CDC connector to process change data from an SAP source, right? So most of the magic happens in the source transformation. This takes care of reading the right data from the SAP side, doing the deduplication, taking care of the order of things, interpreting the change mode as it comes in the technical fields ODQ change mode and ODQ entity counter correctly, and basically transforming this into ADF internal row markers. And then basically you can define your own logic in subsequent transformations and apply the data to any sync you would like to have. And with that, I'll hand it back over to Noel.
Cool. Thank you everyone for joining. Thank you, Ulrich, for walking us through everything. That was super awesome. And it was great to see that demo and see how easy it was to do the Change Data Capture. For everyone who is watching, again, if you have questions, continue to post them in the comments. This will be saved on our YouTube channel so that you can continue to come back and rewatch it. And of course, if you really found this video to be helpful and you liked it, like and subscribe. And we will see you next time. Thank you all for joining.
Thank you.